language is basic. And then what do I want you to do? Go over it again. And then do what? Go over it again. Then do what? Go over it again. Then do what? Go over it again. Instead of spending a lot of time on each slide, spend a little time, make a few notes, and then reread those notes and reread those notes. How did you learn the alphabet? Practice makes perfect. A, B, C, D, E, F, G. Now I know my ABCs. Tell me what you think of me. Okay? So, that's how we learn. Is saying over and over and over and over. And I'm going to try and get through this real quick, but let me make a little comment to many of you that are originally Spanish speakers. This would apply, by the way, to anybody from any language in the world. You've come to the United States for whatever reason, or you were born here either way. But your first language, many of you, is Spanish. I respect that. Do you want to prosper and succeed in life in California, in the United States? I'm going to tell you straight up, and you may hate me for saying it. If you can speak English like I do, the likelihood of succeeding in whatever career you choose is much better. Much better. Is that true? I guarantee it's true. How will you do it? I'm going to tell you, many of you make a terrible mistake. You go home and watch Spanish TV. Stop it. Only watch English-speaking TV and learn to talk like those stinking Hollywood actors. Okay? Why? Because that's the way President Obama talks. Does President Obama, the nation's first black president, does he talk any Ebonics? He talks like a well-educated, brilliant man, and he does. He absolutely does. And you listen to him talk, and I want you to. Listen to the way he talks. He talks well. He communicates. He's a master communicator. But can you imagine him running for president going, well, dog, or whatever, Ebonics, and let me ask you a question, man. You're not going to get to be president that way. And that's true whether it's Spanish, whether it's Ebonics for black people, whatever it is, it doesn't matter. And I don't want to spend a lot of time on this crap, but it's so important to you. How will you learn to speak like I speak? Am I good and better than anybody else? No. I was born with this language. I grew up with this language. The accent I had as a child was Minnesota, which is a little bit different. I lost it in California. But that was an advantage I had over some of you. It was. I didn't deserve it. Doesn't make me better than anybody. Got nothing to do with anything except if you want to succeed, you got to communicate well. Now, when you speak Spanish, then speak Spanish well. If I were to move to Mexico, and I've often considered it, particularly I've considered moving to Spain. My wife and I have actually talked about it. We spent time in Spain. I had an apartment in Madrid one year. I guarantee you, I would do nothing but watch Spanish-speaking television, listen to Spanish-speaking radio, and I would want to speak that language right if I was going to have a career. Why? I want to succeed. The issue isn't English. The issue is, in Rome, do as the Romans do, is the issue. Let's go on. Okay. I had time for that because how fast we're going to get through this. We're going to get through it what we call, in good English, muy rápido. Now, again, you need to know what GPS and GIS. I believe there's a question on one of them. What do you need to know about it? What the word letters mean. All right? What the letters mean. Duh. That's it. Okay. Projections, not on the test. Nothing here is on the test. Pass by. You've got to know these three kinds of scales. Fractional, graphic, and verbal. If you do not, you're going to miss an exam question. I'm telling you straight up. You need to know fractional, graphic, and verbal. That's it on this slide. Fractional, graphic, verbal. Are these other words important? Yes, but I'm going to get to them in the next slide. This is the legend. It gives us information about the map. What is a legend? It gives information about a map. These are contour lines. The difference from one to another is called the contour interval. It's 200 feet, according to the legend. That means the elevation difference. The closer the contour lines are together, the steeper the slope on a topographic map. On a map of temperatures, this is called an isotherm. It separates this color from that color. Here's another isotherm, separating this color from that. Here's another isotherm. See it? Separates this color from that. It's isotherm. It's about temperatures. These are isobars. Do you need to know all three? Contour lines, isotherms, isobars. Yes, you do. All three. All right. The closer the isobars are together, the faster the wind blows.
What was the line? It was contour line and what else?
Contour lines, isotherms, like thermometer, like thermostat, meaning temperature. These are lines of equal temperature. These are lines of equal air pressure. What is an isobar? Line of equal air pressure. Everywhere on this line is exactly 30.2 inches of mercury. Do you need to understand that?
No.
Not basically, no. Now in the second exam, yes, because we're going to talk a lot about these. All right. Where the lines are close together,
The wind blows fast.
the wind blows faster. You have a steeper gradient. You see it? A steeper gradient. Where the lines are close together, you have a steeper gradient. Here, it's topography. That means how steep the ground is. Here, it's air pressure. Right? But where the air pressure is high pressure, that's usually associated with cold air. Not always, usually. And here the air pressure is warm. Air blows from the poles to the equator. Remember I told you that? From cold to warm. So the air blows from cold to warm. Right? If warm and cold are far apart, the air doesn't move very fast. But if the two are real close together, they got a hurricane. You got really high-speed wind. Does that make sense? All right. The shorter the wavelength, the more intense the energy. Do you need to understand that? Yes, yes, and yes. Absolutely. Is it important? Yes, yes, and yes. I want you to know that X, gamma, and ultraviolet are solar energy wavelength. It's intense. What does that mean? Dangerous. Dangerous. And the Goldilocks planet is going to protect us from that. The atmosphere of the Goldilocks planet is going to protect us. So do you think the word Goldilocks may be on the test?
Yes.
It may very well be. I can't remember. If I remembered, I'd tell you. I don't remember. I think it is. These are called solar energy wavelengths. The longer wavelengths are called, remember this word? Terrestrial.
Oh, yeah.
You remember that word? Terrestrial. Why is that important? Terrestrial wavelengths of energy warm the air. Solar energy heats the earth. But terrestrial energy warms the air. Terrestrial wavelength energy is longer wavelength energy. Do you remember that? Longer wavelength energy. All right, all of this you need to know for the exam. Not everything here you do. I'm just going to hit I spent a lot of time talking about microwaves. Why? Because microwave energy penetrates water. Do you remember that? And we can use microwave energy receiver to see, as it were, the bottom of the ocean. The Amazon underneath the clouds. We can see it from satellites. So microwave radiometry has become very, very important in modern meteorology. By the way, how long is the wavelength of a microwave energy wave? The answer everybody in this room knows. How do you know? It's longer than the holes in your microwave oven. If it was shorter than the microwave oven hole, it would come out. You'd look in there and it'd burn your eyeball out. It happened in about a quarter of a second. I'm not joking. But those holes are smaller than the wavelength, so the wave hits the solid above the hole. And it bounces back and warms up your hot dog. Right? Okay. Is that it? I think it is. Look at that. Now, you all are getting an important idea. I hope you're getting this idea. When you study, I know I said it before, but man, I got to beat it into your heads because I know you guys, you want to go home and watch Telemundo.
No, it's Commander of Estrellas.
Oh, that's what I meant. Okay. All right. The way you study is the way I'm going over it. Fast, fast, fast. And then what? Do it again. Fast, fast, fast. Then do it again. If you study for an hour before the exam, you're going to flunk. Because there's too many things, and many of these things really are complicated. And you're going to see the word radiometry, and all of a sudden, in your brain, you're going to panic.
Yeah.
Have you ever had an exam and you panic? Boy, I have. Why is that? Because you didn't familiarize yourself enough. You see, if I say the word room, okay, room, R-O-O-M, nobody panics. Did anybody panic when I said the word room? No. Why not? Because you all know what a room is. You're familiar with it. When you see the word radiometry on the exam, all of a sudden you're going to say, I remember him talking about that, but what does it mean? And all of a sudden you get all scared, and then you can't even think. Does that make sense? And that is why we do poorly on exams. We've got to become familiar with these terms. Familiar, know them. And then you see the word, you don't panic. You don't panic. Say, I know radiometry. I know what it is. Nitrogen, oxygen, argon, ozone. Carbon dioxide, hydrogen, helium. The sun is primarily hydrogen. Got it? Yep. You do not need to memorize the percentage. You need to know it's mostly hydrogen. That's enough. That's enough. All right. The atmosphere, the air we breathe, and the troposphere consists of two kinds of gases. One are constant gases, which you find everywhere on Earth, and the other are variable gases, which you find differentially in different places on Earth. The constant gases, mostly nitrogen. Do you need to know 78%? No. Mostly nitrogen, that's enough. Oxygen is what we breathe that energizes our bodies. And argon is very common, but it's still less than 1%. But they're in the air everywhere in the troposphere. You can go to the top of Mount Everest, it's going to be the same mix. You can go to the Kalahari Desert in Africa, it's going to be the same mix. You can go to Mongolia, you can go to San Francisco, it's going to be the same. But if you go to Mongolia and San Francisco, you're going to have very different amounts of carbon dioxide and water vapor. Why? Because San Francisco is right on the ocean.